Hello, Algebra 1. This video is to supplement the remediation worksheets we have if you want to retake this section, the exam of Unit 5, Section 1. Okay, so this is kind of a reminder. I know it's been a little while since we've gone over this material, so I thought it'd be nice to revisit it, touch base on it a little bit. So it's not going to be as involved as the original lessons we had when we first went over the material early in the semester, but hopefully it's enough to bring it back to the forefront of your memory so you can complete the remediation worksheet and go on to successfully complete the retake. So this is for Unit 5, Section 1. Unit 5 was dealing with systems of equations, and our first section was identifying the number of solutions of a system, given a graph or given an equation. So in this first video here, we're going to talk about it when given a graph. So let's think about it. When we have a system of equations, we have two equations. And the reason they're systems of linear equations because they each produce a line. So when we draw two lines, we could either have them intersect like this. That's one way to draw two lines. We could draw them so they were parallel like that. Or the other way we could draw these lines, we could draw one here, and this second line just lays right on top of the first one. Okay. So what does that tell us as far as the number of solutions, though? And the solution to the systems of equations is basically the number of points that each equation has in common. Or when looking at a graph, the number of points that each line has in common. So let's look at this first example right here, where we have these two lines intersecting. They intersect at this one point. That point right there is the only point that they share in common. So when you have two lines that intersect like this, you have one solution. Okay, because there's only the 1 point, one solution. How about when we have parallel lines like this? Well, these two lines are going to go on forever and ever and ever and ever, and they're never going to touch. So they're never going to intersect. They're never going to have a point that's in common, a point that is on this line and on this line. There just never will be one. So in this case, there is no solution. And finally, our third case here is what happens when we have one line and then the second equation produces a line that just lays right on top of the first one. How many points do they have in common? Well, every point on one line is a point that's on the other line. And since these lines are going on forever and ever, you're going to have an infinite number of solutions, an infinite number of points that is on one line that is also on the other line. So if you end up with two lines that are laying on top of each other like this, your answer would be infinite solutions. Okay, so just to recap real quick, if you're given a system graphically and they intersect like this, one solution. If you're given a system of linear equations in a graph like this and it's parallel lines, they have no solution. And if you're given a system of equation that produces the same line, each equation produces a line where they lay on top of each other, you have infinite solutions. Okay, so hopefully that helps you identify the number of solutions in a system when you're given it in a graph.